right, thank you, Marianthi. Okay, yes, so first I just want to thank both Marianthi and also Rana and Ander for participating in this work that I'll talk to you about today, that I'm calling Seeing the Invisible, a Novel Epidemiological Approach. So first, as Zayan laid out quite well, this sort of iceberg of pregnancy loss where we really don't see most of it, right? What both Ranan and Zayan were talking about involves this live birth bias. Ranan's in particular, for the biases he's talking about to occur, one of the key factors in both of them is that the exposure, in this case traffic pollution or air pollution, has to affect pregnancy loss. So in order to see if these are really happening, we need to be able to figure that out. But as he also alluded to, that's not an easy question to address because we miss so many pregnancy losses. There's a small literature on air pollution and pregnancy loss that suggests that there is something there, but it's very small and it's very limited, largely because these are things that are very hard to count. We don't see most of them. So even in this, when we can do it, we may have weird biases going on because we may miss so many of them. This is not a problem that is unique to epidemiology. Other fields face this. Physicists faced this when they wanted to study subatomic particles, which are simply too small to be seen. And so the approach they took was to develop something called the bubble chamber, where what they look at is the effects of the subatomic particles on something else. And they look at those something else's to infer what's going on with the subatomic particles. So what we're proposing now is sort of an epidemiology analog to that, where we're going to take advantage of the fact that once a woman becomes pregnant and a conception occurs, only two things can happen. That will result in a live-born child, or she will lose that pregnancy. So there's a sort of defined relation there that we can take advantage of. So with that in mind, I mean, ideally, as epidemiologists, what we would like to do if we want to know whether an exposure affects pregnancy loss is, say, take a cohort of conceptions occurring in some period of time and follow them forward and see which ones are lost and do all the analyses we're used to doing. So in reality, as I just said, we can't do that because we can't identify all the conceptions. We don't even know sometimes that a woman is pregnant. However, as I alluded to, there is a very defined relation between total conceptions and live births and pregnancy loss, and it is simply as illustrated here. TC, total conceptions, is equal to the number of pregnancy losses plus the number of live births that come out of those conceptions. So we can rearrange that then, simply algebraically, and say that live births is equal to total conceptions minus the pregnancy losses, right? And live births are identifiable. We do see those. And in fact, probably now a couple decades ago, Alan Wilcox suggested that live births could sort of be tracked as some kind of crude indicator of whether there were exposures out there that affected pregnancy loss or carrying to term. That's an interesting idea and definitely a possibility. The only problem, as you might note here, is that when you get administrative data on live births, what you're getting is the births that occur in some week or a day or some period of time, right? That is not the live births that I have in this equation here, right? Because the live births I have in this equation here are those that arise from a total number of conceptions in a defined time. So live births, of course, occur at many gestational ages, and so 1 week of live births does not tell you all about the same conception week. So we have to solve that problem first so that we can just get to total conceptions in a period of time, or the observable births that occur from conceptions in a period of time. So this is meant to illustrate how we do this, right? So we now, on the top row here is illustrative. We sort of made up this week-by-week data of total births that you could get from a hospital or anywhere, somewhere. And that's going to fluctuate over time. What we need to do is use the gestational age of each birth to resort them into their presumed conception week, and that's what's shown on the bottom row, right? So what we've got down here is what we're sort of calling a slightly new metric, which is live birth identified conceptions. So it is not all the live births occurring in 1 week, 1 calendar week. It is all the live births that actually occur over a spread in gray in the top row of actual calendar weeks that have come out of presumed conceptions that occurred in a given week. And so now we can track these live births identified conceptions in each calendar week over time and follow those. So for a given conception week now, live birth identified conceptions are those that actually come out of the TC, the total conceptions that occurred in that week. despite you not knowing how many total conceptions there are. And now we have an observable LBIC, or live birth identified conceptions, that's equal to total conceptions minus pregnancy loss. So now, and this here in the next line really should be effect, because we obviously have to control for confounding and things like that. But if there is actually an effect of some exposure X on live birth identified conceptions, it has to be acting through an effect on conception or an effect on pregnancy loss. Those are the only two possibilities. That is modelable in the way we do all of our models, and that's just described down below in a linear fashion, with Z being the covariates that you want to adjust for. It's everything we do. You can do whatever approach you like. We're still left with one problem now, which is that if you do see an effect of some exposure X on these live birth identified conceptions, how do you know whether it's affecting actually the chance of conceiving, or the number of conceptions, or the number of pregnancy losses? So for that, we can look at sort of the pregnancy timeline and exposure timeline, right? We have the arrow here, preconception period, and exposure might occur there. We have conception, there's a gestational period, birth occurs at some point after that, and exposure 2 might occur during gestation. Exposure 1 in preconception, of course, could affect either total conceptions, or it could affect pregnancy loss in ultimately affecting the observable live birth identified conceptions. Exposure 2, by definition, can only affect pregnancy losses because it occurs after the conception has occurred. So variation in X, if the X is at exposure 2 time period, cannot affect conceptions because it comes after it, right? Now, of course, there's issues of correlation of exposure 2s, correlated exposure 1. You need to deal with that, and that's sort of confounding control, and I'm sort of putting that aside for the moment, but that's handled in the way anyone would handle it, or any way you would do that typically in epidemiology study. So just to sort of graphically illustrate what I'm talking about here, if you focus for a moment on the exposure X that occurs after conception, and then focus only on the variation in total conceptions that is related to X, there is none, right? So conceptions is what you get. All the conceptions, there's no matter what X is doing, bouncing up and down after the conception period, you're not going to change the number of conceptions because they've already occurred. They're these here. Now those conceptions may be made up of a certain number of live birth identified, kids that go to term and you see in your data, and some number of pregnancy losses that has occurred in the interim that you don't see. So it's made up of both of those. But now we can consider what's the variation in the live birth identified conceptions that is related to X. So if I now tell you that what I'm showing you here is when X is low, we might get a certain number of pregnancy losses, but when X is high, the live birth identified conceptions, which we do see goes down, it has to be doing that in an equal and opposite way to the pregnancy losses. So when you now look at exposures post-conception and how they affect live birth identified conceptions, you are seeing the mirror image of the effect on pregnancy loss, despite not even knowing how many conceptions occurred in the first place. So this has been done pretty much only twice, as far as I can tell, before. Dean et al. in Australia were looking at the effects of a mass shooting that occurred in 1996, and they did essentially the same approach. They're saying registered pregnancies here is essentially what I'm calling these live birth identified conceptions, and they found that if that mass shooting occurred in the first trimester, there was about a 30% reduction in the live birth identified conceptions, or registered pregnancies. The other thing we can do, very interestingly, which Marianthi is going to describe in much more detail next, is we could look at something like air pollution. So here's our live birth identified conceptions in a given week. We can now look at what is the air pollution post-conception during the gestational period, and does variations in that relate to variations in the total number of live birth identified conceptions. And she'll talk more about that. That's in press and epidemiology now. So there are some important analytic considerations to keep in mind when you're doing this. One is, for this approach to work, it has to be done at the group level. So no individual birth tells you anything, right? So whatever analysis approach, it has to be some kind of grouping. The exposures have to be relatively acute so that you can, in fact, isolate them to the gestational period. And very importantly, and this does cause confusion, is that let's say we see an association between some exposure X and a reduction in live birth identified conceptions at a period of gestation. Pick a week 12 of gestation. That does not mean that the loss occurred at week 12, right? The loss could have actually occurred at any point subsequent to week 12, and it was just some exposure that initiated a process that ultimately led to loss. How am I doing on time? I'm okay. Lastly then, of course, so as I said, things that affect conceptions, if the exposure is post-conception, shouldn't confound an association with those exposures. Now, as I mentioned, we have to deal with confounding, and one thing is sort of variation, correlations with earlier exposures. An example of that would be, say, seasonal variation in conceptions. We know this happens. There are periods when more conceiving happens, and there are periods when less conceiving happens. So in an air pollution study, for example, we typically would take care of this by adjusting for seasonal trends. This is very typical in any time series air pollution analysis that you will see. For singular events like a mass shooting, of course, you could do that. You could also look at what happened in the year before over the exact same time period, or the year after in the exact same time period, and take out that sort of seasonality effect. And then, as Marianthi will talk about a little bit more, there may need to be some slight variations on typical approaches to doing these analyses. As I say, we're now looking at live birth identified conceptions at 1 week and exposures after that week. Typical lag analyses go the other way, but she'll talk to you a little bit about that. So with that, I just want to thank our funders at NIEHS and also my team at Harvard, but especially these guys here on the symposium who all contributed to these thoughts. Thank you very much.